Right, I is an imaginary number. It equals the square root of minus 1. Now, if I draw the unit length on an Argand diagram as a complex number with real and imaginary parts, the Cartesian form is cos theta plus I sine theta. The polar form, using Euler's identity, is e to the power I times theta. Now I can make some simple statements with this. When theta, the angle, is 0, my line goes along there, the real axis, and the expression just equals 1. When I make an angle of 90 degrees, or pi over 2 radians, I get e to the power pi over 2 times I equals just the imaginary part, I. Remember, that's just a unit length. And I can spend another 180 degrees. I get e to the I pi equals minus 1. And just for finality, if I go 270 degrees, I get e to the power I times 3 pi over 2 equals minus I. All good. Now that brings me to my original question. What is I to the power I? Or an imaginary number to the power of the imaginary number. Or the square root of minus 1 to the power square root of minus 1. I can rewrite that as e to the power natural log of I, all to the power I, because this bit's just the same as I. I can bring the power to the power, you multiply them together, e to the power I times the natural log of I. But this part here, the natural log of I, this is just what I have to raise e to get I. And I know from up here, if I raise e to the power I pi over 2, I get I. So the natural log of I is this value here. So the natural log of I is I times pi over 2. Now if I substitute here the natural log of I for I times pi over 2, I get e to the power I squared times pi over 2. Now I squared is minus 1, so the whole thing boils down to e to the power minus pi over 2. Now you can bang this in a calculator and find the answer is 0.2. Well, it rounds up to 0.2. So, amazingly, an imaginary number to the power of the imaginary number, or I to the power I, equals 0.2. Crackers, eh? Okay, there's another way to look at this. If I take that statement there, e to the power I times pi over 2 equals I, and just do a little bit of different jiggery-pokery. That's the original statement. If I raise both sides to the power I, like this, I can see that I've got to multiply this I by that I, the power rule. I times I is minus 1, so I end up with this situation. I to the power I equals e to the power minus pi over 2, which, if you put that in a calculator, rounds up to 0.2. Alright, just another way to think about the same thing. That's wonderful, this, man. It's crazy that an imaginary number to the power of an imaginary number comes out with a real answer. Yeah, amazing.